Hello everyone and welcome to my channel. I'm Alex Fresco and today we are gonna satisfy another request. We will see what is a technological DXF. We will analyze the example that I have prepared in order to have a better understanding on how to get there. And we will see also how to get informations in case we forgot something or we have never been trained on it. Let's immediately start. So I'm gonna import my example file, which is this one, is a side with the toe kick. As you can see, if you don't change anything, it's gonna come in as just as a simple 2D drawing. And well, from here, eventually you can start and apply all the machining. Just to quickly see, if you want to import a DXF like this one and start to apply the machining manually, you will have to select everything, right click, create the panel from the finished geometries. Now I have my panel. Once you have the panels and all the geometries in it, you can start selecting things around, go in machining operation and apply the machining. So diameter, if you want to specify the diameter, otherwise you can go automatic and it's gonna take it from the geometry. So we need just to specify the depth, confirm. The same thing for the other 8mm holes eventually. And for the external is the same thing. So external or actually the grooving. As long as we have geometries, we can select it, go in machining operation, select the milling, select the tool. Now my settings are for actually a through cut all around. So I will have to change something, 1/4 inch down. It's not gonna be all the way through, but maybe, I don't know, 10mm deep. Central correction. And no initial or final extension. And then, and we can keep going. But let's analyze a little bit more this file. I'm gonna import it again. So files, all formats available, double click on it. And here it is again. So what we can see here, that if I go into layers, I can see that there are weird names here and really long. This is gonna depend upon how many things you need to specify for that specific layer. Let me explain better. So whenever we want to create a DXF like this one, the layer name always has to start from the key TCH. So the software can understand that this is gonna be a technological DXF. Then what we see next? We see W. W is the phase where the machining or the type of operation has to be applied. So 0 is the top face of my panel. Then we have 1, 2, 3, 4 that are the 4 sides. And the 5th one is the bottom of the panel. Then what there is next? B. So B allows us to specify which machining operation has to be applied. So B8 are the panel characteristics. So thickness, of course, the length, width, and eventually we can specify on that layer also the origin and so on. Then B1 is the milling. B2 is boring, and then I will show you eventually where to get all these informations. Then TCD is the tool code. In this case, the alphanumeric character has to be specified between the dollar signs. TC is the tool radius correction. Then D is the depth. PT is to enable the through cut or not. Then IT is the lead-in type. OT is the lead-out type. And if these are selected, you can also specify the angle. So the angle for the lead-in and the angle for the lead-out. Like I said, there are a lot of parameters, a lot of things you can specify in these layer names. And so far, we haven't seen really what this file can do for us. So let me open a new program, create a new program, import the same file, but this time I'm gonna use the Technological DXF file import. So double click on the same file, and as you can see, this time is gonna appear not only as a 2D DXF, a two-dimensional drawing, but it's gonna come in also with a proper thickness, all the machining applied. We can optimize the program and play the simulation. It's ready to go. And with a file like this one, you can actually use it directly into the work list without even opening it here in bSolid. So I could go eventually here, work list. Let me create a new work list, import the file, it's not a bSolid file. You can select all types or eventually DXF. And as you can see, now it's in the work list. If I enable the preview of the program, here it is. So it is at all effects a program for the machine, even if it's a DXF. Now, where to get all the information we need in order to create a file like this one? Remember, you always have the guide here for bSolid, so you can click. It's gonna open up all the manual. You can search here for DXF definition. And we can see there are different types. There is the CNI format, which is basically the same thing. It's just I think the BIESSE works is better because you can specify more parameters. The CNI is a little bit more limited. Like I was saying, the BIESSE works. So you can click here. Here you see some of the info. And then remember that when you see a text in this color is a link, so it's gonna bring me somewhere else. So don't be scared about, oh my gosh, there is nothing written basically, it's just one page. No, try to click eventually here and read eventually what are the info, and more specifically we will find all the keys here. So parameters. So mn is the key for a macro name if you want to call a macro. Then like I told you before, W is for the phase selection. Then the type of work, type of machining, the B, and so on. So here you have all the keys you can apply on a technological DXF, and is a long list. But going back to the file, another really interesting thing you can do with a file like this one, like I said, if the file you know for sure is okay, you can run it directly on the machine. Or remember that directly from the work list you also have the possibility to calculate eventually collisions, not only the execution time for the program, but also collisions. So if you are not sure about a program, I would recommend you to click on that before start the program or start the work list. And if the program is okay, you will receive a green check mark here. Otherwise, for any issue with it, it can be a missing tool, or it can be a collision, or it can be, you know, it may be different things. Instead of the green check mark, you will get an orange triangle with an exclamation point. So in that case, you have to go look the simulation to better understand what's wrong with the program. But going back to the CAD/CAM, like I was saying, instead, if you want to check the DXF and open it, you can import the file using the Technological DXF. So it's going to recognize also the machining operation and the panel. And at this point is, as you can see from the right panel, is already a program, and it can be edited eventually. You can double click on the machining operation. If you want to move the coordinates, you can. If you want to change the depth, you can. So I think that is another interesting feature. One more thing to say about the Technological DXF is that we can find all the keys also over here. If we go use the navigator to change environment, we go in general setting, and here we can see the DXF definition. Here, first of all, you can select if you want to work with the BIESSE Works DXF or the CNI, so you can select one or the other. And the keys, you will see the keys here also. Work, blah blah blah, thickness, direction, tool class, you know, you can specify pretty much all you need. Also the type of lead in, lead out, the tool correction, if the tool has to stay on the outside or the inside of the geometry. So you have all the keys, and they are customizable. So if I want to change, let's say, the descent speed, instead of call it with the key DES, I want to change it and use something else, I can just you know, type in something different. Dash, let's say S, so the send speed, because it reminds me that parameter a little bit better. You can confirm it, pressing enter on your keyboard, and save it. We usually don't recommend to change the keys, though, for only one reason, because all the BIESSE technicians and the guys on the phone support know our code, our keys, and so it's gonna be much easier for us to help you in case of you are having problems, figure it out. Otherwise, I mean, not that is impossible, but it will take probably longer to find out what is going on, because we will have to come over here, see what are you using for this specific parameter, then go back to the drawing, and so it's gonna be just longer. That's the reason why usually we recommend to keep our format instead of changing it. So I hope this was helpful. Thank you for watching, and see you at the next video.